Welcome. In this video, we're going to take a look at problem 72 out of chapter 6 in University Physics Volume 2 by OpenStax. All right, so we have a vector field E that is not necessarily an electric field, we can tell by the units, and that is given by E vector is equal to 3x squared times k hat. And we need to calculate the surface integral of E dot n dA, where S is the area that is shown below. And we're going to assume that n hat is equal to k hat. All right, so let's start by writing down the integral. And so we have the integral over S of E dot n hat dA. We can substitute for the E. So we're going to get over the S. E is 3x squared k hat. And let's substitute for the n hat. So we're going to have dot, instead of n hat, we're going to have k hat dA. All right, so we'll put, and k hat dotted with k hat is 1. We can think of A dot B is the magnitude of A times the magnitude of B times the cosine of the angle between A and B. And so for k hat dot k hat, the magnitude of k hat is 1. So we'll have 1 times the cosine of 0 for 1. All right. And the surface integral we can rewrite as going from 0 to A. Going from 0 to A, we'll just have 3x squared. And then the dA we can write as dx dy. All right, so we can say where dA is equal to dx dy. Okay. And so we can integrate 3x squared dx. And so we have 0 to A in the y direction. We have a 3. The integral of x squared is going to be x cubed over 3. We need to evaluate that from 0 to A, and then we have a dy. Okay, the 3's are going to cancel. So we have integral from 0 to A. We have x cubed from 0 to A, and then dy. Okay, so when we evaluate, we still have our 0 to A. Then we'll have an A cubed minus 0 cubed. We can just leave it as 0 dy. So that is just A cubed and then dy. Okay, so that is going to give us A cubed times y evaluated from 0 to A. And this is going to give us A cubed times A, which is going to be A to the 4th, minus A cubed times 0. And so our final answer is A to the 4th. I hope you found this video informative and enjoyable, and I will see you next time.